Okay, guys. Right, my talk's called Testing Django Projects at Scale. And when I talk about scale, I'm actually talking about two things. One is obviously the size of your Django project, how many tests you have, but also within the larger team environment. Hold on. Nope, okay. The other thing to note about this talk is that what I'm going to talk about isn't directly applicable just to Django. It applies to Django, to Python, and actually a lot of them apply to all development in general. Also, I take a very pragmatic approach. Professionally, I worry about whether it's unit test versus integration test versus functional test and all that sort of stuff. But personally, I worry more about the fact that you have tests and not necessarily splitting hairs about the type of tests they are. And I'm also not dogmatic about testing or anything like that. I actually use testing purely for selfish reasons. It requires less work than manually testing. So another thing to note is I have no silver bullet for everyone today. If you're here looking for some technology that's going to solve all your testing problems, I don't have it. What I actually have is just a bunch of practices that you can use to scale your project as it grows and as your team grows. So we're going to cover three main things. What is a good test? How to actually write a test? And then 10 guidelines you can use to help promote writing good tests. So the first thing we'll start with is what is a good test? And like Jacob mentioned yesterday, we like to steal things. This is blatantly paraphrased and ripped off from the Pylons community. So if you're interested, you can go check out kind of what the source material says. But I'll give you kind of a little bit of an overview right now. The first kind of suggestion that they make is tests should be as simple as possible. We want to make sure we're being clear and not clever. We also don't want to write tests that in and of itself require testing. Tests should also run as quickly as possible. So we want to do three things. We want to encourage developers to run tests frequently. We want to encourage running the entire test suite rather than just a subset of tests. And we also want to instill a culture of confidence and reliance on tests. And the last one's really interesting. I've been places where people go, do testing because they go through the motions. They don't necessarily believe in it. They don't rely on it. They don't trust it. My argument there is if you can't rely on your tests and you don't trust your tests, why do you bother writing tests anyway? The next one is this may be a little bit controversial, but stick with me to the end, and I hope I can convince you that this is a good idea. We want to avoid coupling with other tests. So test cases shouldn't extend other test cases in other Python modules. You want to minimize the helper functions that you use from other Python modules. And generally, we all consider dry as well suited for code. It's kind of a practice that we try to strive for, but often it's detrimental when you're actually testing. Finally, tests should clearly communicate intent. Tests should be explicitly clear about what it is they're trying to test. We should have related test methods within the same test case. And then finally, ideally, tests should be self-documenting. And extra documentation is more of a nice to have and not a requirement. If you need to have tons of documentation in your tests, that's a sign that maybe your developer API or the way you've organized your code or the way you're thinking about your solution might be a bit flawed. So next we'll talk about what the canonical form of a test is. Probably we all know this, but just in case. The first thing we want to do when you actually write a test is set up your preconditions. So this means creating the environment we need to run the tests. We maybe are creating model instances. We're setting up the state, creating mock objects, patching methods, functions, objects, that type of thing. Next, we're actually going to perform some sort of test. We're going to run some tests using the environment that we've already established. We're going to call functions, call methods, modify state, and record return values. And then the next thing we're going to do is make an assertion or make assertions about the return values or the side effects of what we've just tested. So we're going to check return values against expected values, test that the state's been modified correctly, and verify that expected exceptions were raised. And then we're not going to do anything else. We're actually going to stop right there. We don't want to modify anything else in that test. We want to write a new test that where we make modifications. So the next step, or the next thing we talk about are maybe some guidelines. And I think that following these guidelines might help promote writing good tests. So to give some context to this, I work at Wave with a few people here. We have multiple products. The oldest product is our accounting product. And it has, or at the time, it had about 5,000, 6,000 tests, and was taking about 35 minutes to run. So it was a very long-running test. We kind of researched and applied some of these principles, and some of these guidelines to that test suite, and we were able to knock that down to about 5 or 6 minutes. And that's without actually applying all of them, given that it's more of a legacy system. Kind of the return on investment of kind of going whole hog and applying all of these across the board really didn't seem worth it at the time. But we were able to get a fairly significant increase in performance. So the first thing we want to do is, again, keep our tests as simple as possible. If a test's complicated, it should raise a red flag that maybe your code is complicated and needs to be refactored. So some common patterns that we see are complex test utilities or test methods that handle assertions for us. Complex tests are harder for a reader of your test code to understand what's going on. And it's also generally adding functionality that should be tested. So I'll give you an example. I have a bunch of examples in this talk from code that we've refactored out, and I took screenshots. So they're not nicely formatted. I basically did a screen grab from Sublime, but we'll kind of go through a few of these. So the first one here is a decorator that we're actually wrapping we're wrapping 2 additional tests with. And what this decorator is doing is alternating between invoice and bill, passing that in as the class, and then running the test. So as you're skimming this, you might think that we're actually running 2 tests, but we're not. We're running 4 tests. That might not be clear to someone immediately as they're kind of going through the code. And to be honest, just write 4 test cases. It's a lot more clear to people who are reading. I think your coworkers will probably appreciate that. The next, and this is, if anything, this is probably one of the top things that you want to focus on, is to only set up the minimum needed preconditions for your test. So again, I'm going to give you an example. So here's a test case, and we have the setup. We do a whole bunch of stuff. You can see we're doing even more stuff. And finally, we're doing even more stuff. So this is in the setup method that's going to run on every test. So I just want to go over what we've actually created here. So we've created a user profile, 28 business accounts, a site, 5 businesses, a currency, a country, a customer, a vendor, a standard account, a test account, an income account, an expense account, a product, a payment term, a GST tax, a PST tax, a test tax, an invoice, 2 invoice items, a bill, 2 bill items. And we actually extended a test case. We've actually loaded 2 text fixtures as well. So now let's look at what we were actually trying to test. We were basically trying to test that when you passed in days until due, that the custom logic we had in the save method didn't modify that in this case. So for this actual, this actual test, we needed absolutely nothing in that setup class. Yet we've added maybe 200 milliseconds to every single test that's in this test case. So you can see over thousands of tests. This might add up and start contributing to long-running tests. The third one is we want to test 1 piece of functionality per test method. I'm going to show you an example of one of our old pieces of code. And you don't need to read this. You just need to notice that the preconditions are in orange and the assertions are in red. So what we've done is we've created some preconditions. We've done some assertions like we said we would. Then we've made more assertions. Then we've gone back and changed preconditions. Then we've made more assertions and so forth. So we talk about scaling, scaling tests for your team. This isn't actually doing your team any favors. We've got 6 assertions, testing 6 different behaviors. We've set up preconditions 4 times, just split them up into separate test cases. As you further on in these guidelines, you'll see why this might be helpful. Next, we want to create preconditions explicitly and resist the urge to use shared helper methods outside of your module. This touches back on the whole dry argument. This isn't dry. So I agree with you, it isn't dry, but shared helper methods tend to grow over time. They tend to cater to the lowest common denominator within your code, and they try to be, so basically they're trying to be generic for everyone to use, and they impose a lookup burden on readers of your test code. When you refactor your test code, you risk breaking unrelated tests in your app. So instead of your tests breaking because you've changed functionality, your tests are now breaking because you've changed test utilities. You no longer have direct control over your preconditions. If you're using a test helper and then somebody decides to add things to your test helper, your test can't be sure about what's happening in the preconditions. And then, of course, anyone can affect the confidence of your tests. The next one, this was kind of interesting. If you need to have base test classes, create them as a mix-in rather than a parent type of test case. So these give us a couple of problems. When a test case extends a base test case that has tests, it actually runs all those tests as part of the test discovery. It leads to the same test being run many times unnecessarily. If we use a mix-in, it's not going to be picked up when you do test discovery. So here's an example from some old code. If you look at this, technically we have 3 tests. So you might say, well, we're going to run 3 tests, but in fact we're actually running 5 because the test values in the base test is being run for every additional test case. This helps you with speed and with kind of helping out your team. Don't use fixtures. Just stay away from them. Use factories instead. Factories are brittle. They're hard to maintain as your project data models change. They tend to get reused in tests rather than generating fixtures for each additional test. And updating fixtures is a pain, even if you have JSON. So if you're adding columns and stuff to your database, you have to go and edit all your fixtures. So if you're using Django, we have something called Factory Boy, which is a Django app kind of based on Rails' Factory Girl package. It actually uses your Django models to generate your preconditions, and you can find that kind of at that website there. It's really easy to use. You define a factory. You tell it what model you want to use a factory for. Then it gives you a whole bunch of utilities you can use, like sequencing and stuff like that. So now what you can do is basically call user factory, and it will give you a new user every time you call it. So we get a couple of benefits. Again, we're using the Django ORM. We get hooks into data preparation and data generation. We can define relationships across models if you have foreign keys and many-to-many and stuff using double underscore notation, which we all know about already. And we can define relationships in Factory Boy to mimic our business logic. Number 7, use Django tests test case instead of unit test 2 test case. And this is actually a huge one for us. You can basically ask every single new person that starts on our team. Without fail, I can guarantee you this happens every new person we add to the team. What'll happen is they'll start writing their tests and everything will be going great, and then all of a sudden, for some unknown reason, the test suite starts failing. For us, it's happened for these 2 reasons. Basically, we have unique constraints on database columns. So as soon as you kind of wrap over, let's say you have a 2-digit ID and you hit 99, and now you need to go back to 00. Well, we already have a 00, so it fails. Or if you have a signal, sometimes the signals can be called and you're not doing cleanup on the things that, or sorry, let me go back. Sometimes what you're cleaning up is, down the road isn't actually what needs to be cleaned up because people may have added signals and stuff to your, based on your models. So basically, if you use unit test or Django's unit test, Django's test case, you can actually get isolated tests because Django's test case runs in a database transaction. So it will get rolled back in between every test, and it actually makes our developers quite happy. The only caveat is if you're like us and you're using multi-DB, the rollback and the transaction only gets applied on your default database. It doesn't get applied on any of your shards or any of your other databases. Number 8, there's some interesting things on the test case class, specifically setup class and teardown class. And what these do is they, instead of doing a setup and teardown and wrapping each test method, you can actually wrap the entire test case. So that actually, we tried doing that, thinking we get some savings. When we actually started progressing more, trying to fix up our test suite, it actually turned into quite a pain for us. So we can't guarantee that all the data gets cleaned up because the setup class and teardown class don't run within a transaction. They run outside of a transaction. So especially with Django signals, if somebody hooks up to one of the models that you have, like a post-save signal or something like that, people may be making saves to your database that your test is no longer cleaning up. If we ever decide we want to do multi-processing for tests, we need to be sure that the test methods can be run in any order. And when you use setup class and teardown class, you can no longer guarantee the order. You have to run the entire test case at once. When we actually put this into practice, the gains that we got weren't really they weren't really enough to justify the work. And when we actually went the route of multiprocessing, we got much bigger gains. The next one is you can start segmenting your tests. So if you're using Django, I would suggest you look at Django knows and knows. It allows you to decorate your test case or your test methods with certain attributes. So what you can do is you can say, wrap your unit tests, your integration tests, or your client tests, things that are using the Django client, that type of thing. This is a little hypocritical because I said you don't want people to run subsets of tests, but we're being pragmatic, so it's still a useful strategy. Some things that you might want to look at segmenting out are things that do URL resolution or login if you continue to use your default password hasher. That's interesting because if you have followed the best practices, you're using maybe bcrypt or something like that for your password hasher. That is a purposely expensive operation, so you're actually adding time to all your test cases if you use your bcrypt password hasher in your tests. Finally, this is probably the biggest thing you can do, is to run your tests in parallel. You can do that with nose and multiprocess, and there's just some sample code that we use to run our tests just in a bash script. Some things to keep in mind: you have to use an in-memory database. MySQL and Postgres don't play well with multiprocess. This gave us the most significant gains as far as increasing the speed of your test suite. One thing to notice that once in a while the test run will go off into the weeds and things will break for unknown reasons, but it's infrequent, so it's still worth using this this mechanism. And to give you an idea about these 10 guidelines, the changes that we've seen, I told you before with the accounting package, we went from a 35-minute test run to maybe a 5 or 6 minute test run. When we actually applied these guidelines up front on some of the newer projects, we have projects that are running, say, 1,200, 1,300, 1,400 tests in less than a minute. Some of the newest projects with our API and stuff like that are running 500 tests in a second and a half. So we're actually, if you actually start down this route and actually use, follow some of these guidelines, I think you can actually see pretty big gains in the speed that you can run your tests. So that's all I have. Any questions?
If you have any questions, just raise your hand. I'll run this out to you.
Thank you. So you made a recommendation. You made a recommendation against setting up a really complex fixture ahead of every test. Do you have a suggestion for how to ration those setups within one file?
Can you ask that differently? I'm not sure quite what you mean.
How would you do setup with a complex fixture with lots of dependencies in a more intelligent way that was less expensive for tests that didn't need it?
Sure. So the first thing is I wouldn't use a fixture. I would, again, use a factory instead.
Oh, okay.
But then I might have, say, private member methods on the test case to set up smaller pieces of my setup. So if you had maybe 1 or 2 test cases that needed all of the setup, then you can run those at the beginning of your test method. But then other methods where you maybe only needed 1 or 2 of the pieces of data set, then you can choose to just run those smaller preconditions when needed. So.
Thank you.
I have a question about test organization. As you mentioned, you had thousands of tests
Sure.
in a project. I was just wondering what your experience has been in sort of strategy and organizing your tests.
I can't use it without saying bad words, I guess. It's not good, right?
Yeah.
We're talking about a project that's, say, 3 or 4 years old. When it started, it was organized one way, and then that didn't scale, so you organized it a different way. Right now so we don't, basically none of our apps have test PY files. We all have like test directories, and then we kind of split that out. Different teams do them differently. Some people do them like unit integration tests in separate files. Some people group files based on the functionality that they want to test. So I don't actually have a good solution. We haven't really figured one out. But I think on an app by app basis, we kind of choose the best way to organize it.
Like recently in projects, what I've been doing is basically mirroring my application so that every module has a test, and like it kind of goes like unit by unit and kind of just shadows exactly like the production code. But I don't know if that's ideal either. I mean,
sorry, you mean the
so
order?
like if I have a module that performs a certain task, I will have a test in a test directory with the same name as that file, and it'll basically go line by line, sort of in a chronological order to kind of like mimic that structure of that test or the code. But I don't know if that's it.
Yeah, I'm not sure. Like, maybe I don't understand fully, so maybe we could talk after. But
Yeah,
I
sure.
know when you use things like multiprocess and stuff, you can't really guarantee the order anymore. That may break down if you try to use multiprocessing. So,
Cool.
Any other questions? No? All right. Once again, thank you, Ash.
thank you.